Hi again, welcome to another video. In this one we are going to talk about adding up or summing the terms in a geometric series. In some respects this is not as exciting as discussing the adding up of terms in an arithmetic series, but it's probably going to be more important. The topic leads to being able to solve a variety of very practical problems, especially in finance settings. In the previous videos, we have established that for a geometric series, there is a constant ratio between successive terms, and we determine that by dividing one term by the previous term. Mathematically, we can say that r is equal to Tn divided by Tn minus 1. And second, we can express the nth term mathematically as Tn is equal to T1 times r to the n minus 1, or we can simply say that the nth term equals the first term multiplied by the common ratio raised to the n minus 1. The approach to determining a computational relationship for the sum of a geometric series is much more mundane than discussing Gauss. The sum of a geometric series can be written as Sn, sum of n terms, is equal to the first term plus the first term times the common ratio plus the first term times the common ratio squared, and so on and so forth. We now multiply that expression by r for every term, and we get what you can see, r times Sn is equal to T1r, etc. And now we subtract the two equations, one from another. So I'm going to do Sn minus Rsn. The T1 term in the top one remains, but all the others cancel out until we get to the last term in the second equation, which has no counterpart in the first one. So we're left with, on the right hand side, T1 from the first equation minus T1 r to the nth in the second equation. Now we can factorise out the Sn and then divide by the 1 minus r, and we get our computational relationship as Sn is equal to T1 times 1 minus r to the nth over 1 minus r. So the sum of n terms of a GP is calculated by taking the first term and multiplying by a fraction, the numerator of which is 1 minus the common ratio to the nth over 1 minus the common ratio. Notice in this case that the r in the top is raised to the nth term because we have all n terms having to be involved in the sum. So for the formula that I've shown here, we need a bit of explanation as well. The formula can be used in all situations for calculating the sum of n terms of a geometric series. Some people, older people, suggest the alternative formula, Sn is equal to T1 times r to the nth minus 1 over r minus 1. In other words, the terms are reversed. It's just the same formula. People think it's different and they write it differently. No, it's just the same. Just factorise out a common factor of minus 1 from numerator and denominator in 1 and you get the other. Other people say it's computationally easier. It's not. Most people now use that modern invention called the calculator. You just put all terms from your formula into the calculator at the one time. It is irrelevant if the ratio is greater or less than 1. And also using this format has the advantage that you have exactly the same denominator as you need for limiting sum calculations, which we address in the next video. In other words, you're not going to be thinking in the exam, oh, what's the denominator at this stage? It's always the same, 1 minus r. So off the soapbox and into an example. Find the sum of the first 10 terms of the series 4 plus 12 plus 36. Well, on the left, we've written the first term, T1, as 4, and 12 over 4 is 3, so the R ratio is 3. We substitute in. The sum of 10 terms is equal to the first term, 4, times 1 minus the ratio, 3 to the 10th, over 1 minus 3. Put that in your calculator, as you can see in the diagram, and you get 118,096. Really straightforward. A second example. Find the sum of the first 20 terms of the series 36 minus 6 plus 1, and so on and so forth, to 2 decimal places. Well, the first term, T1, is 36. The common ratio is minus 6 over 36, which is minus 1 over 6. So we substitute. Sum of 20 terms is equal to the first term, 36, times 1 minus the common ratio, which is minus a sixth. So we'll put it in brackets, all raised to the 20 because that's n, divided by 1 minus 1/6. Put it into your calculator, as we can see, 30.86. Now we do another example which is slightly different. And before we go on with it, just think, if in the formula we've got Sn, we've got the first term, we've got R, the ratio, and we've got n, the number of terms. The questions are always going to revolve around, I'll give you 3, you find the fourth one. So in this case, we're going to find n. So the sum of n terms of the series is 2 plus 4 plus 8, and that gives us 510. So the first term is T1 equals 2. The common ratio is 2, but we don't know what n is. So substitute. 510 is equal to 2, which is the first term, times 1 minus the common ratio, 2 to the n, over 1 minus 2. Tidy that up. The denominator gives us a negative, so we've got minus 510 divided by the 2 from the right-hand side, and that's left with the bit in brackets, 1 minus 2 to the n. Tidy that up, 2 to the n is equal to 256. Now we can do that a couple of different ways, but I'm taking the longer way because it's the more general way and using logarithms. So n is equal to log 256 over log 2, also using the change of base law. And so putting that in my calculator, which is still a very useful thing to do because it's modern, n is equal to 8. So in summary, we have one basic formula to use to find the sum of n terms of a geometric series, and that is that Sn is equal to T1 times, bracket, 1 minus r to the nth over 1 minus r, which is, if we say it to ourselves, the first term times 1 minus the common ratio raised to the n divided by 1 minus the common ratio. So easy, so simple. Excellent. So you now have the steps to apply to be able to calculate the sum of a geometric series, and there's variations within that, of course. Hope I've helped you to clarify the approach. Thanks for watching. In the next video in the series, we look at the limiting sum of a geometric series, which is where we have the ratio of less than 1. Go and do some questions in test 1 on my website, drjsmaths.com. Before you go, hit the like button and subscribe if you haven't already. Add a comment or send me an email if you've got any questions. Good luck. Hope you've enjoyed it. See ya.